Welcome to part 2 of the slider puzzle tutorial. So far we've created our grid, and as I said in the previous part, we'll now be looking at how to unwrap the tiles and assign a texture. We'll also be looking at how to clean the scene so that we're not having to manually delete our puzzle each time we run the code. We'll also be printing out a percentage so we know how far along our script has got, as it can get a bit slower later on. So that's what we're going to do next. We're actually going to do a new function, so I'll create a bit of space at the top, and we're going to call this percentage print, open and close brackets, and then a colon. Well, what things do we need to work out a percentage? And also, why am I doing this as a separate function? Well, firstly, we're going to want to print out the percentage at each different stage of the code. So it makes sense to be able to reuse this code. So in each of our sections, we can call this percentage print function, and it'll print out the percentage for that specific section. And then when we get onto the next section of code, say the texturing, it can also call this code and start printing out the new percentages. So it's reusing this code. Well, something that's going to be unique to each time we print out the percentage is perhaps the name of the section it's on. So for example, when you're creating the grid, you might want to print out grid something percent complete. So grid 20% complete, grid 100% complete. So you're going to need to pass in that grid name because, you know, later on it may be the animation stage, so it'd say animation 20% complete, animation 100% complete. So that's something that's going to be different each time. So when we call this function, we're going to tell it which name we're going to want it to print out. So I'm just going to define a variable called print name, and we can now use that variable in our function. Something else we're going to have to pass in, and something that's going to be different each time it runs, is the total number of times it's going to run. Because the way you work out a percentage is how far along you are in something divided by the total. So we need to give it a total each time, because the total isn't going to be the same. So I will do a comma and total. And you'll see when we call this in a second how it works and how we pass in those variables. So for the minute, I'm going to define a new variable called percent, and I said it was equal to how much of the way through we are of something divided by the total. So I'm going to use a variable we haven't defined yet called total counter, and I'm going to divide by the total and then multiply that by 100, and that's kind of the standard calculation for calculating percentages. And this total counter is going to be something that is defined globally, and so currently this percent variable is what's called a local variable because it's defined within the function, but a global variable is something like this up here. It's defined outside of a function. Now, when you want to access a global variable, for example, this name variable, which is global, we're accessing it down here, and that's fine. You can read it absolutely fine. It's when you want to change a global variable from within a function that you need to kind of import it. So we're going to do global total counter. And what that says is look outside of this function for the total counter variable. And we will be defining that in a second. So we're importing our total counter. We're working out our percent. And then we need to print something out. So I'm going to print a couple of spaces, a couple of tab spaces, plus the print name. Remember, that's the thing we're passing in as one of our arguments, plus a space, plus the percent, plus one final piece of text, which is percent complete. And like last time, this percent is going to be a number, so we need to convert it to a string to be able to add it to the rest of this text. And then we're going to increase our total counter by 1. Because each time it runs, it's going to have increased by some percent. So we're just going to do like we did with the name, plus equals 1. So I'm going to call it every time this code is run. And so it has to go in the inner loop. Remember, we called it percentage print, and it's expecting two arguments. It's expecting the name that it's going to print out. So in this case, it's going to be grid. And it's also expecting the total number of times it's going to run. It needs that to work out the percent. We're going to pass in another variable called total pieces, which also hasn't been defined yet. So I'm going to define this up here. So I'm going to move it down a bit, and total pieces, well, if you think about it, the total pieces equals the number of sides multiplied by the number of sides. So in a grid that has 4 tiles per side, it's going to be 4 by 4, so 16, which makes sense. We've got 16 here. So total pieces equals whatever number of sides is multiplied by the number of sides again. So in this case, it'll be 16. If the number of sides was 5, it'd be 25, and so on. So back to our percentage print. We've now got a total pieces variable. That is the total number of times this will run. So let's see what percentage print is going to do with these. So percentage print is taking that print name, which we put as grid, and it's just going to add it into our printout message. It's also taking in the total, which we've told is total pieces, and in this case it's going to be 16, and it's going to take our total counter, which we haven't dealt with yet, divided by our total. Well, this total counter is just going to be defined below total pieces. It has to be global, so that's not inside a function, because multiple functions need to be able to access it. The create grid function needs to be able to reset it each time it runs, and the percentage print is going to need to access it so it can increase it each time it runs. So total counter equals 1. That's just creating it initially. We then want to reset it when this runs, because this total counter is going to be used by multiple functions, so we need to make sure we're resetting it when this runs. And because it's a global variable, we need to tell it it's a global variable. So you can see we're getting pretty good result, but one thing I'm going to do is I don't really feel that we need to have this decimal place. So I'm going to wrap this percent in another function called round, and I'm putting this inside the string function. So it's being rounded, and then it's being converted to a string. So if we run it again, we're getting this nice neat list. And because we've got this tab, or these couple of tab spaces, it's creating this indentation, making it very easy to read. So I'm just going to select everything and delete it, because we've run the script a few times now, so the pieces will be building up. And that leads on to the next kind of useful function we can do, which is to get rid of the existing tiles when we create the grid. So create a new function called clean scene, and that's where we want to set the initial layers when we first run the script. So what we can do is bpy.context.scene.layers, but this time, instead of accessing an individual one, we can actually load in a whole list. Because I did say earlier that the scene.layers is a list of true or false values to say which layers are visible. So we can actually load in a new list, and we do that with square brackets. And so this is going to expect 20 values for the 20 layers. So I want the first layer to be visible, so that's going to be true. And then after that, everything is going to be false, because I want every other layer to be invisible. So I'm just going to copy this and then paste it another 18 times. And just to check that that's working, we now have to call this function, because remember, just because we've created it, we're not calling it. So obviously we want to clean the scene before we create the new grid. So clean scene. So we can now set any layers, run the script, and it always returns to layer 1. So now the first thing we need to do is make sure we're in object mode. And this is actually something we need for the rest of the scene as well, because a lot of these operations will depend on you being in object mode, not edit mode. So something we can do is check which mode we're in, and then change to object mode if we are in edit mode. So if we hover over this value, we can see that the way we would set it is using ops.object.mode_set and then setting the mode to edit. But to check which mode we're in, we use bpy.context.mode. So what we can do is have an if statement. If the mode is equal to, we use a double equal sign for comparisons, and then we're going to check the value of edit_mesh and then a colon. So if we're in edit mode, then we use the command bpy.ops.object.mode_set, and we are setting the mode to object, and then another value we just put in is toggle equals false, because we're not toggling, we are setting it definitely to object mode. So if the mode is edit mode, set it to object mode. And then a second thing we can do is something we did earlier. So I'm just going to copy this line and just make sure everything is deselected. So that's part of cleaning the scene, but the major part is, like I said, deleting the tiles that are already there. So we need a way of looping through all the objects in the scene, and Blender does obviously store a list of all these objects. So in the same way we did this loop down here, we can loop through our objects. Instead of looping through this range, we can actually loop through the list. And we do this by saying, in the same way, for, and then again we can use any name, but because we're going to be looking in a list of objects for each individual object, it makes sense to say for object in bpy.context.scene.objects. So what I'm basically saying is loop through this list of scene objects, and each time this runs, it's going to load that object into this variable here. In the same way that when we did for I in range, the range number was loaded into this I variable, and we were able to use it as part of the location. So then, although we're looping through all objects, we can do a second check to make sure we're not deleting other objects. So for example, if you had cameras or lights in your scene, you wouldn't want to delete them, we only want to delete the tiles. And we can do that by checking for the name of the tile. So we already have our name variable at the top. Name is puzzle1 piece. So all we have to do is check to see if the name contains that phrase, and if it does, then delete it. So we can say if name, which is our variable at the top, and then we can use the keyword in, like we did above for object in bpy.context.scene.objects. So we can say if name in object.name, and then a colon, because we're doing an if statement. So this is saying for every object in the scene, load that object into this variable. So this is going to contain a single object from the scene each time it runs, and then we can access the object's properties. So if the name contains puzzle1 piece, then object.select equals true. We want to select it, and then bpy.ops.object.delete. So that's the same thing. If we press delete here, we can see it's using bpy.ops.object.delete. And remember, we're calling it before we create the grid. So let's run this script. We're not getting any errors. And if we look here, we've not got any duplicate grid. So now we don't have to worry. If we want to change the size of our grid, it'll delete the old one and put the new one in place, whereas before it would just keep on putting them on top of each other. So far we have created our grid, we've positioned it, we've got the percentage printing out, and we're getting rid of the old grid before we create the new one. And the next step we can do is unwrap these objects and apply some textures. So what I'm going to do is change to the UV image editor, and if you remember right at the beginning, we created that material and we loaded in a texture, and this is just a texture I made in Photoshop, And the main point of this texture is that it's got quite a lot of detail in the background. Because if you think about it, we're creating a puzzle that's going to be kind of mixed. So if you've got large areas that are all the same colour, you're not actually going to be able to tell if the puzzle is mixed or not. So having lots of detail in the background will make it a lot easier to see when the code is working and when it's not. And what I just want to do at the beginning is make sure that I've got this name, because we are going to be referencing this name in the code. So now we can change back to the text editor. I was just making sure that I knew the name. And so I mentioned earlier that Dave Leake on Google Plus suggested a modifier I could use that would mean I didn't have to merge the objects and separate them later. And that modifier is the UV Projects Modifier. So what I'm going to do is minimize this window for a minute. I'm going to go onto layer 4 and I'm going to go into top view and create a plane. I'm going to tab into edit mode and I will bring back the UV image editor actually, and I'll press U and project from view, so it's unwrapped it. So if we go into textured view, we can see our texture loaded on. And I'll just move it up and I will create a new plane. So we've got a new plane below it, and I'll just press U and reset, and I'll just rotate this and remove the image. So the point is, although this has been unwrapped because it's a plane, this is representing one of our tiles. That's why I just rotated it, just so the image wouldn't display properly immediately. And the UV Project Modifier, well, it projects an image onto another object and alters that object's UVs so the image can be displayed properly. And I will just show that. So I'm going to call this object up here Projector. And on this object, I'm going to add the UV Project Modifier. I'm going to say I want to load in that texture we just had, and the projector we're going to use is Projector. And we do actually need that image there so we can display it properly. But what you'll notice is that without this modifier applied, we're getting the original UVs. But as soon as I turn this on, it's correcting itself. And that's because this image here is being projected onto this object. And to show that, we can move this object around. So the UVs are in a diamond, which I made, so they were imperfect. But if we apply this modifier, then it corrects them, because it realizes, well, to project this image correctly, this is how the UVs have to be altered. And so that's what we're going to be doing in our code. We're going to be applying this modifier, projecting the UVs, and it basically means we don't have to do the step of joining objects and separating them out again, which is the whole point. So I'm going to delete this test object here. We are going to keep this object because we're going to use this as our projector. And remember, it is called Projector. I'm going to clear out its location with Alt-G, just so it goes back to the middle. And then we'll go back to our code. So we're going to do the unwrapping in a separate function. So at the bottom, I'll define a new function called unwrap. So the first thing I'm going to do is another loop, because basically we've created our grid and now we need to loop through those objects to apply our UV Project Modifier. So we're going to do for I in range again, and we're going to go between 1 and total pieces. Remember, our total pieces variable is the number of sides times the number of sides plus 1. And that's because if you remember when we did the test for the range, it goes up to, but not including the last number. So then again, I will create a current piece variable like we did before, because it's going to be easier to access our object. I'm going to say current piece equals bpy.data.objects, and then we want to loop through all the objects, and the way we can do that is by using our name variable and then adding on the number of the loop, which is I. So each time it runs, it will say I'm looking for puzzle 1 piece, and then it will say puzzle piece 1, puzzle piece 2, 3, and it will go up to but not including that total pieces plus 1. But again, because we're adding a string and a number, we need to convert this to a string. So each time this runs, it will store one of our puzzle pieces. And so at this point, we can just test that by saying we want to print out current piece dot name. So we can bring back our system console, and we've got to remember to run the script. So after we've created the grid, we will unwrap, and you can see I've made a slight mistake in the spelling, which threw up that error. And if we run it again, it's printing out the name of all our objects. And it's quite useful to do these print statements every so often just to make sure your script is working. We don't need that anymore. The next thing we want to do is repeat the steps that I did when I was showing you how the UV Project Modifier worked. So the first thing we want to do is add a new modifier. Now that we've got our current piece, we can access the current piece modifiers just by .modifiers. And we can show that just by, as a test, accessing this object here, which is puzzle1 piece 5. We can do bpy.data.objects, and if I press Control space, it gives us all the possible options at the minute. Accessing puzzle1 piece 5. If I do a dot, and then Control space again to autocomplete, we can see all the options here. And you can see there is a list for modifiers, which allows us to access the list. So if I just type in modifiers, we can see that it's listing the modifier we added, which is UV Project. But if instead of accessing the list of modifiers, I did a dot, we've got the option to add a new modifier. And you can see it's expecting the name of the modifier and the type of the modifier. So we can do current piece.modifiers.new. The name is going to be UV Project. And that's just the name we're giving it. That doesn't actually matter. That can be anything. So that's just this field here, which is just the name. And the type, this is where it does matter, is UV_project. So this should loop through all the objects and add a modifier to them. So if we run that, we can see that every object now has a modifier on it. And the way that we would access the modifier now is through that list. So current piece.modifiers. When we access a list, we can use the numbers. So the first modifier in the list is going to be number 0. But having to type that again each time is a bit of a long thing to do. So we can just replace that again with a variable. So we're now storing that first modifier in a variable called modifier. And that means we can access properties of the modifier very easily just by typing this word. So you can see here, uvproject.image, we can just type modifier.image. So what are we going to set this image to? Well, we're going to set it to that image we loaded in before. But seeing as we're going to be using it in multiple places, it makes sense just to load it in once at the top, outside of the loop. So I'm going to say texture equals bpy.data, and instead of objects, as we've been doing so far, we can access images, because images are also stored as data. And if we remember the name that we used, it was texture.png. So now we can say that the modifier.image equals texture. So we'll make sure that all works. And you can see we're getting an error. And that's because I've failed to spell modifiers correctly. So if we try that again, there we can see that the modifiers have all got that texture loaded in now. So the next thing we need to do is change this projector. And although you can't quite see it because the Python tooltip has been shortened because it's a bit long, we're actually going to be accessing the modifier.projectors, because there can be multiple projectors. We're going to say we want the first projector object to equal, and that's our projector object that we've got on layer 4, which is bpy.data objects and we called that projector, and that's this object here that we set up earlier as a test, and we are actually going to be using it. And then I'm just going to say modifier, and we're going to be accessing this override image property, and that just makes sure it replaces any image that's on there, which means it'll display in textured view correctly. So setting that checkbox to true, and again running that, we can see those options have been loaded in correctly. We're then going to set our active object again to this current piece, so then we can apply our modifier. So we're going to say, as we did earlier, scene.objects.active equals current piece, so making the current piece active, and then we're going to be running this ops.object.modifier.apply, which you can see in the tooltip. So we're just going to and we have to specify which modifier we want to apply, because obviously there could be multiple modifiers. And this is where we specify the name that we used up here. So we named it this, so we can copy it. And that's the name of the modifier we want to apply. So if we run that, we can see what we get. And if I change into textured view, we can see we're getting our image projected on top. But something that's not quite right is to do with the size that the projector is. So if I just comment out this line that applies the modifier and run it again, and bring back layer 4, we can see our projector object. And you can see it's affecting everything. But really, what I want is for it to be the correct scale. So it should be something like this. I wanted the whole image to be projected over the whole puzzle. So to do that, we need to work out how big to scale our projector dependent on the number of sides that we've defined the puzzle to have. To do that, outside of our loop, we will access our projector object in the same way we've accessed all the other objects. We'll access its scale property. Remember earlier we were accessing a location property, and in the same way we can access scale, and we're going to say scale equals, and we're going to provide it with 3 values now, so we can set the X, Y and Z scales at the same time, and we're going to say number of sides divided by 2, and then a comma, so that's the X value. And now for the Y value, we're going to do the same, number of sides divided by 2, and then the Z value, that can stay at 1. So if we run that, our scale is now correct, and our textures have been applied correctly. Now, if I bring back layer 4, we can see what it's done is scaled up the projector to be the number of sides, which would be 4, so 4 and 4, which would obviously be too big, and then dividing it by 2 gets the correct value. So now we can again change this number of sides to anything, and our image will always be the correct size because our projector is being scaled correctly. So the next thing we can do is add in some print statements like we did before. So I'm just going to copy this one and put it at the top here, but instead of creating grid, I'm just going to say unwrapping, and then at the end unwrapped, and then we will also add in our percentage print function, and we've got to remember that this has to be inside the loop so that it runs every time. So if we type percentage print, remember it's expecting 2 arguments, both the name that you want it to print out and the total that it should use. So I want it to say that each time it prints out, it should say unwrapping, and the total is going to be the same as last time, which is total pieces, because that's how many times this loop will run. So if I bring back our console, let's run that. And so you can see we're getting a bit of a problem. The first one prints out correctly, so we're getting the correct percentage, but then it just continues from 100%. And that's because we need to reset the total counter variable. So that's this total counter that it's using. We reset it in the create grid, and so I'm going to copy these two lines, and we're going to do the same in unwrap. So we need to reset it, but it's a global variable, so we're going to tell the function to access the global variable by typing global total counter before we reset it. Now if we run it again, we can see we're getting the correct results. And what we can now do is add a few extra items to our clean scene function. And that's because when an object is used as a projector, it has a user, because something is using it. But even when we delete an object that has a UV Project Modifier on it, and so it is using a projector, it doesn't get rid of the user on the projector object. So even though we've only got 16 objects, it's saying it's being used by 187 objects, because each time we run our script, more are getting added, even though those objects are technically deleted. And that's because Blender won't get rid of those users until the file is reloaded. So what we can do is actually clear out the users for it each time we run the script. So what we can do is, inside the function but outside of the loop, we can add projector, and we can use the command user clear. Now, I don't think it actually matters if this number keeps on going up, but I think it makes sense to clean up as we go. So now, it just says 16, because that's how many objects we have. Now, a similar thing is happening to the image that we're using. So we're using a texture. And the same thing is happening. So we're also going to clear the users for the texture. And we do that with data.images, it's not an object. Remember its name is texture.png.user clear. And again, that has worked. So that actually concludes part 2 of the tutorial. In the next part, we'll be looking at how we might move the pieces, which involves locating the empty square in the puzzle that pieces will move into. We'll also be creating the core algorithm of how to create a list of the possible movable pieces for every move.